Hello student, how are you? I'm Arun sir. Welcome to my channel Tuition Expert. Today in this class I will teach you the heat transfer, that is conduction of heat. Student, if you follow my class attentively and watch my video regularly, then I can assure that you must crack the iitjee exam and NEET exam confidently with good rank. Now let's start about the class. So today topic is heat transfer. Now first we learn how heat is transferred, that is how heat is conducted through a slab, through a rod, etc. Suppose here a hot reservoir and a rod is connected between, this is hot reservoir temperature T1 degree centigrade, this is a rod and here a cold reservoir, this is a cold reservoir temperature T2 degree centigrade. Okay, now T1 greater than T2. So we know that heat transferred from this reservoir to this reservoir through the rod, that is heat is conducted. First we learn how heat is conducted. Heat a energy. So how heat is conducted? Conduction means we know heat, that is energy transferred but not the matter. Molecule is not transferred, molecule is at their own position, only heat energy is transferred. What is the cause of heat energy? So at the heat reservoir, the molecule of the medium has very great vibrational energy. That is, at hot reservoir, all molecules of the medium have great vibrational energy. That is, in this way the molecule vibrates. Now these high vibrational molecules collide the molecules at the surface, at the end surface of the rod. Now this collision creates the vibration of this molecule. Now this vibration of this molecule transfers its vibration to the next molecules. That is, this way the heat is transferred, that this way heat is conducted from one position to another position. That is, vibration of the molecule is transferred one by one. So this way heat is conducted from this to this. Now what is the amount of heat conducted? Suppose Q equal to amount of heat conducted in T second. L is the length of the conductor. Length of conductor. Okay, length of conductor. A is the cross section area. This cross section is A. A is cross section area of the conductor or rod here. Theta 1, suppose T1 is temperature of hot end of the rod. T2 equal to temperature of cold end. Now Q is, what is the value of Q? The formula is Q is proportional to temperature difference of hot reservoir and cold reservoir. That is temperature difference between two ends of the rod. Q is proportional to this area. That is, as area is more, amount of heat conducted, amount of heat transfer is also more. Q is inversely proportional to the length of the conductor. So as length is more, amount of heat transfer will be decreased, and Q is proportional to time. We know if time is more, then amount of heat transferred or heat conduction is also more. So Q depends on this factor. Now if we combine this factor, combine this factor, the Q is proportional to T1 minus T2 into A into T by L. So Q equal to, when we put equal sign, then a constant term is here. This is important constant term, K into T1 minus T2 A into T into by L. So now this term, this constant term is important. So this constant term is called coefficient of thermal conductivity. Coefficient of thermal conductivity. Now what is the unit of coefficient of thermal conductivity? L is centimeter, T1 minus T2 is degree centigrade, and area is centimeter square. So unit is calorie, centimeter cancel, calorie centimeter, and T is second, calorie second, and T is second here. So K equal to, what is the value of K? To find the unit, now what is the, to find the unit of K, what is the value of Q, what is the value of K? K equal to Q into L into T. Now CGS unit, what is the CGS unit? Q is calorie, okay, L is centimeter, and T1 minus T degree centigrade, area is centimeter square, and T is second. So unit is calorie per centimeter per degree centigrade per second. This is the CGS unit. CGS unit and SI unit will be, calorie per second. This is in SI unit, that is joule per second. This is water, joule per second. This is water, joule per second. This is watt meter. Degree centigrade is denoted by Kelvin, watt per meter Kelvin in SI unit. And what is the dimension? Dimension of K will be, M L T to the power minus 3 theta to the power minus 1. This is the dimension of the K. We can easily understand what is the area and what is the length. That is, if heat is transferred at this phase and emits or emerges from this end, then we can say that we take the cross section is A, that is A equal to pi r square if r is radius and length is the length of the rod. Now if we take, suppose a slab, suppose a metal plate, if we take a metal plate, suppose heat is enter in this side and heat emerge from this side. So if the thickness is, this thickness is D, and this is, suppose length is L and this breadth is A. Now area will be here L into A, and thickness D equal to the thickness. So here heat supplied will be K into, suppose this temperature is theta 1, this temperature theta 2, theta 1 minus theta 2 into area will be AL, length into breadth, that is this area is N to L divided by the thickness. Thickness means the heat is transferred, the heat is conducted through this length, that is, this is the thickness. So here the answer will be this into time, 40 seconds. So the heat conduction for this figure will be this. Here the heat is transferred or heat is conducted through this length D, and area is this phase. Area will be area of this phase, and theta 1 is the end of this phase and theta 2 is the end of this phase. Theta 1 is greater than theta 2, obviously, because heat is entered here and emits from this phase. So this is the heat conduction. What is thermal resistance? What is thermal resistance? Denoted by RH. What is thermal resistance? So suppose this area is A, length is L, temperature T1 or theta 1, theta 2, theta 1 greater than theta 2, and this area is A. Now heat conducted in T second will be K into theta 1 minus theta 2 into T into A by L. This is the amount of heat flow in T second. This is the amount of heat flow. Amount of heat flow in T second. This is the amount of heat flow in T second. Okay. This is the amount of heat flow in T second. Now, rate of heat flow, what? Q by T, rate of heat flow Q by T equal to, we can write this theta 1 minus theta 2 by L by AK, L by AK. We can write this expression as this. So, Q by T. So, now watch this formula. If we compare the electric current through the wire, if we compare the electric current through the wire, what is the electric current? We have studied it class 10. Electric current when pass through a wire whose resistance is R. What is the Ohm's law? Ohm's law is if potential at this point is V1 and potential at this point is V2, what is Ohm's law? Ohm's law is I equal to V1 minus V2 by R. This is the Ohm's law. V1 is potential at this point. V1 is higher than V2, so that's why current is current passes through this resistance. So this is the formula of current by Ohm's law. V1 is potential at this point. V2 is potential at this point. R is resistance of the wire. Now if we compare this, and what is I? I equal to charge by time, Q by T. Q by T equal to this. So if we compare this and this, then Q by T equal to V1. This term is compared to V1, and this is V2. So V1 minus V2, then we call that this is the thermal resistance. So here this term is replaced. This term is like this term. So this is called the thermal resistance, because if we called R is electric resistance, then by similarity we can say that this term is thermal resistance. We can say this. We know resistance equal to rho L by A. So here also L by A present, and rho we know for resistance, electric resistance, rho equal to resistivity. So here 1 by K is resistivity of the heat. Now this is rho equal to, what is the rho? Rho equal to 1 by L by A, conductivity. So here K is also called conductivity. K is called conductivity. The reciprocal of conductivity is called resistivity. So 1 by K is resistivity of heat. 1 by K is resistivity of heat. 1 by K is resistivity of wire. So that's why K is conductivity, thermal conductivity of wire. 1 by K is here, 1 by K is thermal resistivity of wire. So K equal to thermal conductivity of wire. Thermal conductivity of wire. So this term and this term is similar term, and thermal resistance equal to L by AK, length by area into thermal conductivity, coefficient of thermal conductivity. Now we can find the equivalent thermal conductivity. Next term is equivalent thermal conductivity of two rods or slab when connected in series. Equivalent coefficient of thermal conductivity of two rods when connected in series. This is equivalent coefficient of thermal conductivity of two rods when connected in series. Now, suppose what is the series connection? If two rods are connected in such a way, suppose this is one rod and this is another rod, coefficient of thermal conductivity of two rods are different, and suppose this is hot and temperature T1, suppose this is hot and temperature theta1 and cold and temperature theta2, and the length of this rod is L1 and length of this rod is L2 and cross section area is A. If the what is the series connection? If the cross section area of the two rods are same, length may be different, coefficient of thermal conductivity may be different, but the area must be same, and amount of heat supplied, we know that heat conducted through the series is same. So Q is same, means rate of heat flow also same for both rods. Then we say that these rods are in series connection. Now what is the equivalent thermal conductivity? To find the equivalent thermal conductivity, compare with electric circuit. Suppose this is a resistance and this rod is a resistance. This resistance is R1, this resistance is R2. We know the R equivalent for electric resistance, R equivalent equal to R1 plus R2, R equivalent equal to R1 plus R2. For electric resistance, R equivalent equal to R1 plus R2. Now if we compare this, so R equivalent here, thermal resistance equal to L by AK. What is the length? Length of the two rod is L1 plus L2. Now for thermal conductivity we consider a single rod. So to find the equivalent thermal conductivity, thermal conductivity coefficient of thermal conductivity, which is denoted by K. To find the equivalent thermal conductivity of two rod, we consider the two rod as a single rod, that is single rod whose length will be L1 plus L2 and area is same. So the temperature theta1, theta2 all are same, and amount of heat supplied, that is rate of heat flow also same. If length is L1 plus L2, cross section area is A, and the temperature of hot and cold end also same, rate of heat flow also same, then we can say that this rod is equivalent to the two rod. So if the resistance of this rod is R, then we can say that R equal to R1 plus R2 by electric or for similarity of electric resistance, R equivalent equal to R1 plus R2. Now what is the R equivalent? R equivalent equal to L by AK, L1 plus L2 by AK, A into K equivalent. So this is this, and R1 equal to L1. For equivalent resistance we know R equivalent equal to R1 plus R2. So this is R equal to L by AK, length of the single rod, L1 plus L2, area is same, K equivalent, this is the value of R equivalent, R1 equal to L1 by AK1 plus L2 by AK2. So from this we get L1 plus L2 by K equivalent equal to L1 by K1 plus L2 by K2. So this is the formula. This is the formula. This is the L1 plus L2. So this is the formula. Now if three rod or four rod are connected, if three rods are connected of length L1, L2, L3 and conductivity, thermal conductivity K1, K2, K3, then we write this way. So on. Four rod connected, we write so on. Now special condition is that, special condition when L1 equal to L2. When L1 equal to L2, then what happens? So put L1 equal to L2, we get when L1 equal to L2, we get 2L1 K2. Now 2 by K equivalent K2. So this is the formula. K equivalent equal to 2 K1 K2, 2 K1 K2 by K1 plus K2. This is the formula. K1 K2, 2 K1 K2, K equivalent K1 plus K2. So this is the formula when L1 equal to L2. If length are not equal, then we use this formula. This formula for two rod, this formula. So this is the formula of coefficient equivalent coefficient of thermal conductivity. Now next topic is equivalent coefficient of thermal conductivity of two rods, TVT of two rods when connected in parallel. Now what is parallel connection? Suppose two slabs or two rod is this. This is one slab and this is another slab. Cross section area A1, A2 are different. Now these slabs is connected in one heat reservoir, and these are so two rods are connected in both common two reservoir. One, this is a hot reservoir, temperature T1, and this is cold reservoir T2. So two rods or two slabs connected in same hot reservoir and cold reservoir. Now what is the condition of parallel connection? For parallel connection, length must be same. In series connection, length may be different, but cross section area be same. But here for parallel connection, length must be same, cross section may be different, A1, A2, this is A1, this is A2, and this temperature is T1, this temperature is T2, this is hot reservoir, this is cold reservoir. Now if Q1 is the amount of heat flow through this rod, Q2 is the amount of heat flow through this rod, and coefficient of conductivity is K1, K2 for the two rod. Now to find the equivalent conductivity of two rod, we imagine one rod whose, now to find the equivalent conductivity of two rod, we imagine a single rod whose cross section area will be A1 plus A2, length will be same, and amount of heat flow will be Q1 plus Q2, and this rod also connected in the hot reservoir whose temperature is T1 and cold reservoir whose temperature is T2, that is T1 T2 be same and length same, area area of the cross section of the rod, single rod, will be A1 plus A2, that is sum of the area of two rods, length will be same. Then this rod is set to the equivalent of two rod. Okay, so for equivalent the length must be same. The single rod must be connected in both hot and cold reservoir whose temperature also same, that is this is T1, this also T1, this is a hot reservoir, cold reservoir T2, this is also T2, and amount of heat flow must be sum of the amount of heat flow through the two rods. Area of cross section must be sum of the area of the two rods. So now this single rod is said to be equivalent of the two rods. So what is the value of Q1 plus Q2? Now we find this equivalent conductivity K equivalent by the formula 1 by R equivalent equal to 1 by R1 plus 1 by R2. As this is parallel, so suppose this resistance is R1, this resistance is R2, this is R equivalent. In parallel connection, equivalent resistance is equal to this. Now R equal to, we know, L by AK, L1 plus L2, A into A is A1 plus A2, and K equivalent equal to 1 by R1, that is L1 by A K1, and R2 L2 by A2 K2. So these are the formula. Length will be. Now R equivalent, what is the formula? R equivalent L by AK, L by AK L by AK this. So K equivalent equal to A1 K1 plus A2 K2 by A1 plus A2. This is the formula of K equivalent. For three rods, K equivalent equal to A1 K1 plus A2 K2 this three rods. If A1 equal to A2, special case, then we can say that K equivalent equal to, if A1 equal to A2, then we can say that by 2A1, so 2. If A1 equal to A2, this is the special case, then K equivalent equal to this. If A1 equal to A2 equal to A3, suppose for three rods whose area is same, then K equivalent will be A1 plus A2 plus A3, A2 plus A3 by 3. So this is the three rods connected in this way. Suppose conductivity of this rod is K, this rod is 2K, this rod has K by 2. Double of this conductivity. In this way, the question are given in this way. The rod ABC, three rods are connected in this way such that coefficient of conductivity, such that thermal conductivity of B is double of A and thermal conductivity of C is half of the conductivity of A. Now if this this end temperature of this end is suppose 100 degree centigrade and this end temperature is 90 degree centigrade and this end is 60 degree centigrade, what is the junction temperature? What is junction temperature? Given length and cross section area are same for all the rods. So what is the answer of this question? this end has 100 degree centigrade, this end is 90 degree centigrade, this end is 60 degree centigrade. Now what is the temperature of the junction? What is the junction temperature? That is theta at here. So to find the answer, suppose Q amount of heat is flow through the rod. The rod is the heat will be conducted from this end, because this is the higher temperature among the two. So the heat is conducted from this end, and Q is divided into Q1 and Q2. This is the path, and this path is divided into two paths. So Q is divided into two paths, like the water flow. Suppose this is a pipe, and from this section two pipes are emerged. Now the water will divide it into two paths. So like this, the heat flow also divided into two rod. So we can say that Q equal to Q1 plus Q2. Now if we divide it by T on both sides, then this will be the rate of heat flow. Now what is the formula of rate of heat flow? Rate of heat flow formula will theta 1 minus theta 2 by L by AK. Theta 1, theta 2 are the temperature of hot and cold reservoir. This is the thermal resistance. So if we apply this formula at here, what is the formula? Formula is 100 minus this temperature, say theta, divided by L by AK. This length L, area also same, so L by AK. Now Q1 by T equal to theta minus 90 by L by AK A into 2K, plus this is theta minus 60 by L by A K, K is K by 2. So this, so L by AK cancel from both sides, L AK cancel. Solve this, you get the value of theta. So 100 minus theta equal to theta minus 90 by 2 plus by 2 means this 2 is here, and theta minus 60 by 2. So from this we get 4 theta and 2 theta, 5 plus 7 theta equal to this. So theta equal to 0, at the degree centigrade. So this is the answer. Now next topic is growth of ice on lake. In cold country, in the lake where temperature is less than 0 degree centigrade, suppose minus 10 degree centigrade, or it may be minus 20 degree centigrade, there the ice is generally formed on the water of the lake. So how ice is formed in the lake? Suppose this amount of ice has already formed, and after that dy y is the thickness of ice has been already formed. Now dy is the thickness of the ice formed in time dt second. Now below that, this is water, and surface area of the ice is A. A is the surface area. Now the surrounding temperature is minus theta degree centigrade and water temperature is 0 degree centigrade. Now to form the ice, this amount of ice heat must be rejected. So from this heat is rejected to the surroundings. This is hot reservoir, this is cold reservoir. So heat is rejected from the hot to cold. Now what is the amount of heat rejected to form the ice of mass dm? Suppose this dm is the mass of ice formed in dt second. Now what is the mass? Mass equal to volume into density, whose value is volume equal to area into length. Area is A and length is dy. Area, this is the volume into density. Rho is density of the ice. So now amount of heat rejected from this will be dq equal to k into 0 minus theta, that is theta, into area by y in time dt, that is suppose time is t or dt. Now what is the value of dq? dq will be mass into latent heat. We know from 0 degree centigrade to convert 0 degree centigrade water to 0 degree centigrade ice, the heat rejected should be mass into latent heat. So dq will be mass into latent heat. So this equal to k theta a dt by y. Now dm equal to what? dm equal to a into dy into rho into L by y. So cancel a from both sides. So what is the equation? Equation will be y dy rho L equal to k theta dt. Now if we integrate this theta is constant because surrounding temperature is constant. If we integrate from time t1 to t2, and when time t1 the y has the value y1, when time t2 y has the value y2, then we can put this y1 y2 here. So what is the value of this? Y square by 2 y1 y2 equal to k theta t2 minus t1 . So half rho L suppose t2 minus t1 is the time interval t. So this is the formula. Time interval t2 minus t1 is denoted by t. So this is the formula. So from this it is obvious that time taken to form the ice of thickness double, triple, etc. is, from this equation we get that the time taken to double, triple the thickness of ice is for double, triple, y1 equal to 0 and if we put y2, suppose y thickness ice has been formed in time t. So to find double thickness, the time will be 1 square, 2 square, 3 square, in this way. The ratio of the time taken will be in this way, and the time interval to change the thickness from 0 to y, then y to 2y, then 2y to 3y, etc. This time interval should be 2 square minus 1 square, then 3 square minus 2 square, then 4 square minus 3 square. So these are the time interval. Should be 1 square minus 0 square, 2 square minus 1 square, 3 square minus 2 square. These are the time interval. These are the time interval. So put here, we get this time interval. Student, this is the end of the class today. To get more problems, to get important problems of this chapter, watch my another video. Okay, thank you.